In the depths of the sky wanders light, silent in its journey through the endless night.
Welcome, Comet Chasers. This month we focus on the wonderful and historic comet 12P Pons-Brooks, but there are two other comets visible in small telescopes that also deserve your attention. These two other comets, 13P Olbers and C2023A3 Tsuchinshan-ATLAS, are every bit as exciting. 12P Pons-Brooks continues to put on an amazing show in images this month. It is a bright comet that is easy to spot in small telescopes and even binoculars, conveniently placed in the evening sky. If you have never spotted a comet in your telescope or binoculars, now is your chance to do so. At the onset of the month, the comet is situated in the constellation Aries, exhibiting a brightness of magnitude 4.6. Observers should note a coma spanning 6 arc minutes, characterized by a central bright diffuse spot at the center. As the month progresses, the comet is expected to gradually increase in brightness, transitioning into the constellation Taurus by the month's conclusion. Visibility of Comet 12P is primarily from the northern hemisphere and the equatorial region, appearing low in the western evening sky. The comet will progressively descend each night in the sky. Observers at latitudes of 40 degrees north and above will find the comet too low to observe post the 25th of the month. In contrast, observers in the southern hemisphere will start to gain visibility of the comet from the 6th, with its position slightly elevating each subsequent evening. Currently, there are no indications of naked-eye visibility for this comet in our predictive models, although there exists a possibility for detection from high-altitude sites by seasoned astronomers. Achieving such an observation poses a significant challenge unless there is an unexpected increase in the comet's brightness. This drawing of 12P Pons-Brooks was made by Deirdre Kelligan on the 29th of March from Killadoon, Ireland, a Bortle 2 sky. She used an 8-inch, 200mm Dobsonian telescope at a magnification of 38 times. The comet was 12 degrees above the Atlantic Ocean. She said, "The comet was quickly found by hopping from Jupiter to Hamal and then to the comet by moving right from Jupiter." She described what she saw as follows. The center of the coma looked extra white, dense, and bright. The rest of the coma looked round like an Alka-Seltzer doing its thing in water. I could see no tail against the sky or other structures within the head. I wished I could grab the comet and put it in any other darker spot in the sky. Because this comet has relatively little dust, what we see in the telescope is primarily the round coma with just a stub of a dust tail, as she has drawn. The intricate gas tail is too faint to see, especially in twilight and so low on the horizon. Now, in photographs, it is a different story. Even under these adverse conditions, astrophotographers can capture amazing images of the gas tail by stacking as many images as they can reasonably take while the comet is above the horizon, often selecting only the best images. This image was captured on March 28th by Michael Yeager using a modified Nikon Z6 mirrorless camera. He used a 50mm lens at f2.8, stacking 10 80-second exposures. This remarkable image by Gerald Riemann and Lucas Demetz was captured on March 5, 2024, using a 20-inch plane-wave telescope located in Spain. A Larsen-Sekanina filter was applied to bring out the detail in the coma, clearly revealing a spiral pattern created by at least 3 separate jets of gas and dust. Jets like this are relatively rare in comets, but we knew from the drawings made in 1884 and 1954 that this comet was likely going to have a lot going on inside the coma. In this image of 12P, the galaxy M33 is seen in the upper right. It was taken on March 22, 2024 from West Virginia by Alexis Kwasinski. He used an SV-80 telescope with a 0.8 times focal reducer. The tracker was a ZWO AM5 and the camera was a ZWO ASI 2600 MC Duo. Alex said that the processing was extremely challenging because of working with a mosaic, bright moonlight, and the comet averaging about 10 degrees off the horizon. The mosaic consisted of 2 tiles, each consisting of 34 45-second exposures. This image by Pilot Astro was taken near the end of March from Friesland, Netherlands, using a TS Optics 115 f7 triplet APO telescope and a ZWO ASI 533 MC Pro camera. It consists of 30, 90-second exposures. Note the presence of 3 distinct colors. The green in the round coma, or head, of the comet is likely due to diatomic carbon and cyanogen molecules that are ionized by the sun's light, causing a green glow. The blue in the tail is mostly due to carbon monoxide ions, which easily interact with the solar wind, blowing them quickly away from the comet and forming the gas tail. The larger dust grains move much more slowly. Sunlight scatters off these particles, often scattering some colors more than others. In this case, the dust has a brown hue. In big, bright, dusty comets, it is usually more white in color. This image by Satoru Murata was taken outside of Albuquerque, New Mexico on March 30th, using a Skywatcher 100 ED telescope and an ASI 071 MC camera. The image consists of a stack of 32 30-second exposures. There is a link to his Instagram in the description below. Be sure to check it out. On April 8th, there will be a total eclipse of the sun visible from a swath across North America. At that time, 12P Pons-Brooks will be about 24 degrees to the east of the sun and will be visible in small telescopes and possibly binoculars. However, we do not encourage people to try to view it during the eclipse. The eclipse will last only about 4 to 4.5 minutes. Your time is much better spent taking in the solar corona and your surroundings during totality. If you can set up a camera to run automatically during the eclipse, then go for it, but don't let it distract you from the main event. If you have never seen a total eclipse, there are 3 things you should know. 1. Eclipses are an indescribable and almost spiritual event that everyone should witness at least once in their lifetime. 2. In order to witness the eclipse, you must be situated in the narrow eclipse path of totality. 3. The next total solar eclipse in North America won't be until 2044. Hold on a minute. I'd like to make a plea for you to stick around for a bit. As 12P Pons-Brooks disappears into the western horizon and the sky darkens, another comet is very nearby. This is the equally interesting comet 13P Olbers. If you already have your telescope set up for 12P, why not try for it? 13P Olbers is very similar to 12P. It too is a long-period Halley-type comet with a long history of returning to the inner solar system, in this case about every 70 years. It was the next periodic comet to have its orbit determined after 12P, thus catalogued as 13P. It was discovered by Heinrich Wilhelm Matthias Olbers on March 6, 1815, when it was faintly visible to the unaided eye. When it returned in 1887, it was recovered by William Robert Brooks, who co-discovered 12P Pons-Brooks. Like Comet 12P, it returned in the mid-1950s, only 2 years after 12P. This month, both comets are visible in the evening sky. Headline writers are always looking for some sort of once-in-a-lifetime hook, which is usually more hype than reality. But this really is a once-in-a-lifetime chance to see both of these historical comets on the same night. 13P Olbers is an evening comet visible from both hemispheres. It is moving through Taurus, east of the location of 12P Pons-Brooks, making it higher in the evening sky. This means it can be observed after 12P sets in a fully dark sky. From 40 degrees north, it is visible in a small telescope all month from a dark site. In country skies, it can be spotted in a 6-inch telescope. After April 29th, it will be visible in small telescopes from the brighter country skies. It is magnitude 10.4 and brightening rapidly. Look for a 2.5 arc-minute coma with a diffuse condensation at the center. C. 2023. A3, Tsuchinshan-ATLAS is likely going to be famous in the months to come, regardless of how bright it is in the fall. Because it is currently predicted to reach a maximum brightness of magnitude 2.3 in early October, careless people might assume that this is going to be a bright, naked-eye comet, especially when the additional effect of forward scattering is considered, which could make it much brighter still. People are fond of saying that comets are unpredictable, and they are to an extent, but Greg Crinklaw, the astronomer behind this channel, points out that most comet disappointments are set up by the unrealistic expectations of humans instead. Even if it is quite bright at the moment when it passes close to the sun, the observing circumstances play a major role in how good our view will be. We will do our first analysis of this comet's prospects later this summer, and for good reason, because a lot can change between now and then. But all that aside, we are very much looking forward to finding out what this comet has in store for us. In the meantime, it's already available in small telescopes and conveniently placed in the evening sky. 2023 A3 will be visible in small telescopes from a dark site and under country skies after the 26th. It is best observed around midnight, allowing plenty of time to observe 13P earlier in the evening. It begins the month at magnitude 11.6 and will brighten by about 1 magnitude by month's end. Look for a small 1.5 arc-minute coma with a diffuse spot in the center moderately condensed. In the quiet afterglow of 12P Pons-Brooks departure, the stage is set for 13P Olbers and C 2023 A3, evidence that the night sky's parade of comets never truly ends. Each night offers a fresh act in the cosmic ballet, where even the unsung comets play star roles. So when good weather comes along, take advantage and consider spending an evening under the stars with our night sky guests. Happy comet chasing, everyone.
In the depths of the sky wanders light, silent in its journey through the endless night. A tale of ice and dust, gracefully it slides, captivating us as it silently glides.